हेलो हेलो स्टूडेंट्स, गुड मॉर्निंग। आप सबको मेरे यूट्यूब चैनल पे स्वागत है। तो इस क्लास में हमने एक 12th क्लास फिजिक्स का एक टॉपिक बेस चार्ज फर्स्ट चैप्टर का एक डेरिवेशन है। दैट इलेक्ट्रिक हियर दैट title is the electric field intensity due to a uniformly charged ring or circular loop. So according to that one, that title, I had drawn this figure here. This is a ring, okay, and which is on the surface of this ring uniformly charges are distributed linearly, okay, along the line. Ring means what? A line is bent in a circular form, and here that charges are distributed over it. That charge is distributed. That charge is what? Charge is what? Q equal Q, and we know that Q, this is the total charge distributed, and we want to find that electric field due to this uniformly charged ring at the point here, this point, and that point is at a distance of x distance from the center of the dipole, and whose radius is a, okay. So this is a right angle triangle. It is a right angle triangle. By using right angle triangle, this distance also we can find. That is that equal to r equal to what? X square plus a square 1 by 2, according to Pythagoras rule. And to find the electric field due to this whole ring, but we are taking in a small fractions. That is a small length of this ring, whose length is dl, and this is a, we are calling as a current element. So whatever charge is present over this element, no, that also producing electric field. So that electric field at this point is in the direction of like this, okay, in this direction, okay. That small element producing small electric field, that is dE, and this dE is making one theta angle. This dE making and theta angle with the line joining this point and center of the ring. This is making an angle with this line, okay. That is that is theta, sorry. That is theta, okay. And we know that electric field is a vector quantity, so it is resolving into two component. That one component is along this line, that is called horizontal component. Horizontal component is dE cos theta. Perpendicular to this one is dE sin theta. So now we can find electric field here, but one more assumption we have to make it here. That is the what assumption? Not assumption, it is a real fact. It is, if you take one more component opposite to this element, if you take one more element opposite to this same in length and charge, it is also making one same type of pattern of electric field at this point, but in opposite direction, okay, in opposite direction. This point we are taking as a P, and here this it is also making one angle like this, okay, like this it is making angle, and here it is also resolving into two component. And here this is vertical component, okay, and this one is resultant, that is DE, and this one is horizontal component, that is DE cos theta. Okay, but here these two components are opposite to each other, they are cancelled. So similarly, number of opposite elements which are producing horizontal component and vertical components of each pair are cancelling. So only there will be horizontal component. Okay, so therefore the electric field due to this whole ring is given by that is equal to E. Okay, that is equal to E is equal to what? Due to this all horizontal component. So it means here I am taking here sigma to show, or we can write here, or we can write before that equation, we can write net electric field net electric field electric field at P due to whole ring whole charged ring, you say whole charged ring whole charged, we can say here particular word, because that word is compulsory, because that ring is placed in due to that is uniformly charged, whole uniformly charged ring uniformly charged ring that I am taking here, E equal to sum of all horizontal components. Okay, horizontal components here. So therefore we can write here, that is DE cos theta plus DE cos theta. Similarly, many are there, n number of n number of are there. So instead of writing this form, we can write sigma DE cos theta due to what? Of whole ring you can write here, whole ring. And this same we can write in integral form, that is integral, here also you write whole ring, and here that is DE cos theta. Take equation 1 here, take equation 1. So from this linear density, the charge density, that is linear charge density is what? That is equal to charge divided by charge over that. Okay, this is total charge. Okay, and dq divided by dl. So we can write here charge dq equal to lambda into dl here. Okay, so this you take equation 1. Okay. Now the electric field intensity due to this element at this point, general form we can write, general form of electric field at P due to dl element, otherwise we can write here charge lambda dl, that is equal to what? That is dE cos theta, dE equal to 1 by 4 pi epsilon naught. Epsilon naught charge is what? Lambda into dl, and the distance is ap square, okay. So therefore dE 1 by dE equal to 1 by 4 pi epsilon naught lambda into dl divided by that distance is what? Square root get cancels, therefore x square plus a square will be there. This is the electric field due to that element at point P. Now by putting this value here in this equation, I putting this value here, that is that value is what? Therefore net electric field at P due to whole ring, that is E equal to integration of dE value is substitute here this value, that is 1 by 4 pi epsilon naught delta lambda into dl divided by x square plus a square. Don't write here this square, this much only. And here this cos value we can write. What is that cos? This cos value, from that cos is what? Cos equal to base by hypotenuse. Base is what? Base, that is cos theta equal to what, beta? Base by hypotenuse, base is x divided by hypotenuse is what? X square plus a square 1 by 2. So now whatever terms constant are there, you take outside. This is also here also write whole ring. So therefore E equal to whatever terms constant are there, you take outside, lambda into dl divided by 4 pi epsilon naught, and here that is x divided by what? X divided by this x divided by that dl you write there. dl should be here only. There only. Otherwise x also you take constant, that is also take here, and and this simplified form, what is simplified form here? That is x divided by, bases are same, that the bases are x square plus a square, here 1 is there, and it becomes 3 by 2 into integration of dl. So here integration of dl is nothing but what? It is the circumference of the ring. So therefore right here, that is E equal to lambda divided by 4 pi, that is x divided by x square plus a square to the power 3 by 2, and here this integral dl we can write, that is 2 pi a. What is 2 pi a? Give the reason. dl is what? dl is equal to what? Circumference. Circumference, that is equal to 2 pi, or r means what here? E, radius. R means radius it is. R means here radius. Okay. R means here radius of the ring. Radius of the ring. And here I am continuing this side. This side I am continuing. So here this will be the what? Here, see here. Length into length into this length into this lambda is equal to what? Length into lambda. Length into lambda is what? That is equal to q. Okay, but since total charge q equal to, that is lambda into that length is what? 2 pi a. Therefore this equation becomes E equal to what? E equal to 1 by 4 pi epsilon naught qx divided by x square plus a square to the power 3 by 2. So this is what? This is total electric field due to that ring at point P. At point P. This is net derivation, exact derivation. But here some cases are there. Cases. First case is what? Case 1. If that point is point P, if point P is far away from center of the ring. Okay, now far away from the ring, you take ring. Okay, ring. So ring appears as a point. So ring appears as a point. It means what? Here x is very very far than a. Therefore what? Here x square tends to a square tends to 0. A square tends to 0. Therefore electric field will be what? Electric field for that equal to 1 by whatever is there now, that you write here, 1 by 4 pi epsilon naught. In place of that a you write 0. Therefore qx divided by this square cancels, this 2 cancels, and it will be 3. 4 sorry, what it is here? 2 cancels here. This becomes 2. Okay, because this x1 cancels, equal to 2. This is similar to, it is similar to point charge, similar to electric field due to point charge. Okay, it is like this. It is similar, and this is similar. Okay, if point is second case, if point is at center. If point is at center, we can write here at center. It means what? That is at center of ring. Center of ring. Center of ring. It means what? X equal to 0. Center of ring means x equal to 0. In that case, what happens here? This electric field also becomes, electric field also becomes 0. It means what? That is electric field at center of ring will be 0, or we can write here it is minimum. It is minimum. Okay, that is minimum. Third case, where it is maximum, that we can discuss here. Where it is maximum. Where it is maximum electric field. कहाँ पे वो मैक्सिमम है वो भी हमको कंडीशन बताना है. बताने का मतलब कि एग्जाम के सब डिस्कस करने का नहीं, आपको सब मालूम रहना चाहिए कॉन्सेप्ट अंडरस्टैंड करने के लिए. थर्ड केस, वेयर is maximum. Where is maximum? If dE by dx equal to 0, it is condition for maximum. Okay, for maximum. Therefore you write here dE by dx. E value is what? E value 1 by 4 pi epsilon naught d qx divided by x square plus a square by 3 by 2 equal to 0. So whatever terms are there, no, take outside. That is q common. The q is constant, take outside. That is 4 pi epsilon naught, and in bracket of differentiation it will be x divided by x square plus a square to the power 3 by 2, or not 3 by, yes, 3 by 2. Okay, 3 by 2 equal to 0. So this whole term, if you take that side, it becomes 0. Okay, it is 0. So therefore differentiation of this term will be what? So now we can write here in two ways we can differentiate. One, it is in the form of u by v, quotient rule. So this is how it is. It is in quotient form. Quotient rule is what? Quotient rule is like this. Okay, it is numerator and this is denominator, equal to numerator as it is differentiation of denominator with respect to x minus denominator as it is differentiation of numerator with respect to x whole divided by denominator square. This is differentiation rule. So same we can write here, that is numerator as it is, it means x as it is, differentiation of this denominator is what? This one. Okay, therefore that becomes 3 by 2, that x square plus, directly I am putting here that x square a square, and this becomes what, 1 minus, that is equal to 1 by 2 into differentiation of this one is what, 2x minus, and denominator as it is according to that, x square plus a square 3 by 2 into into is what, that is a differentiation of numerator is what, x1 divided by denominator square. What is denominator? That is x square plus a square to the power 3 by 2 whole square equal to 0. I am showing here in detail. Okay, to avoid the confusion, I am putting here, this is 2 cancels, x into x square in bracket x square, this 3 also will be there, 3 right here, x square a square 1 by 2, okay, minus, if you take that side, whole becomes 0, leave it, okay, leave it beta. Therefore here, that is this term you take that side, x square a square, that is 3 by 2, okay, 3 by 2. Now 3x square equal to, here if you take this side, it comes in denominator, okay, that is x square plus a square 3 by 2 divided by x square plus a square 1 by 2, 1 by 2. By simplifying this one, bases are same, okay, in second index law formula, bases are same, power should be subtracted, that is x square plus a square 3 by 2 minus 1 by 2, 3 by 2 minus 1 by 2, that equal to what, that is equal to x square plus a square, x square plus a square, and this a x square, if you take this side, minus, okay, therefore 2x equal to a square, okay, therefore x equal to plus or minus a divided by 2 square root, this is a condition, okay, but length cannot be measured, here direction shows only, in both the side we can put it, either on x-axis, negative x-axis or positive x-axis from the center of this ring, okay, this side or that side, sign shows only direction, okay, at this distance, this side also at the distance of a by square root 2, and that side also a by square root 2, at that distance this will be the maximum, at this distance electric field will be maximum, okay beta, it is complete, no doubt, without any doubt I explained here, okay, practice it and try to understand that concept clearly. Thank you.